Welcome to section 2.5. This section is entitled Equivalent Statements. As the section starts out, we're going to look at a concept of the converse, inverse, and contrapositive of the conditional statement. And then we'll talk more about what it means to be equivalent statements, all of which is going to be handled in the homework. And so let's first start out with this, what's underlined there, the converse, inverse, and contrapositive. They're always based upon the conditional statement. And the conditional statement, if you remember, is P implies Q. That's our base. This is what we call the conditional. And so maybe I'll write that. So the conditional statement that you learned way back in 2.2 is P implies Q. Now, from P implies Q, we now define three other items. The first is the converse. So the converse is basically the flip of them. It's Q implies P. The inverse keeps the same direction as the original, but puts the negation on each. And the contrapositive is the flip of the inverse, so it's the negation of Q going to the negation of P. As you go through the homework, they have the converse, inverse, and contrapositive defined right there in the homework. You'll get used to it. You can bring it with you in your notes when you come to take the exam. But essentially, if we have a conditional statement, P implies Q, then the converse is the flip, the inverse is the negation heading in the same direction, and the contrapositive is the flip of that negation. And it's very interesting. It's actually used a lot. So let's give you an example. One of the things they'll do in the book is they'll say something like, if you study, then you will do well on the exam. Right? They'll start you out with a conditional statement. So this is P implies Q. So P is we study, and Q is we'll do well on the exam. Then they'll ask you, well, write out in words the converse. So what is the converse? Well, if P is, what the converse does is it inverts the two. And it says, if you do well on the exam, then you studied. Right? So notice that it can take on different tense there. So if you do well on the exam, then you studied. And so that is flipping the roles of P and Q, right? Where the doing well on the exam comes first. It doesn't actually have to be the case, right? We know plenty of people that do well on exams that don't study at all. And so even though the conditional statement is if you study, then you'll do well on the exam, its converse doesn't necessarily have to be true. If we do the inverse says, if you don't study, right? It's the negation of P. So if you don't study, then you won't do well on the exam. Now that doesn't actually have to be true either based upon my comments earlier. Like if you don't do well, if you don't study, we're not making any promises there. And so we don't necessarily know that that's going to be the case. Again, they're not asking you to analyze these at this point. They're just asking you to write the converse, inverse, and then let's do the contrapositive. So what would the contrapositive be? Well, it's up at the top of the screen there, and it says not Q. So if I don't do well on the exam, or if you don't do well on the exam, Now, those two are connected. Our original statement in this last one, if I'm making the promise, if you study, then you'll do well on the exam. If you don't study, if you don't do well on the exam, then you didn't study, would definitely be connected there. And we will see that actually through equivalent statements. So in problems 11 through to apologize there. 11 through 30 and even beyond, almost to the end, you're rewriting the contrapositive just like we're doing now. In the beginning and at the end, they're going to go over this idea of equivalent statements. I'm going to define it a little bit differently than they do in the book because I think it makes more sense. So two statements are equivalent if they have the same truth table values. Okay, so that's how I'd like you to know it. So let's look at something that I felt was connected. I felt that the original conditional statement and the contrapositive were equivalent. Let's look at that. So we're going to look at showing that P implies Q and the negation of Q implies the negation of P. We're going to look at the conditional and we're going to look at the contrapositive. Okay, that looks a little bit funny there. Make that look a little bit better, sorry. We're going to look at those two statements and we want to show that they're equivalent. 3 equals lines would be equivalent. We don't know that. We might actually find that they're not, and maybe my perception is wrong. So what my suggestion is create a frequency, not a frequency table, create a truth table for each. You know how to do truth tables by now, right? Having gone and done your homework, being diligent in that. You know it's true, true, false, false, and true, false, true, false. This is the truth table that you have written down. And so you would simply either go look at it and follow it or talk yourself through it. Remember, for the conditional, it's almost always true. The only time it's false is when you've met the premise and the conclusion doesn't happen, right? So true implies true is true. True implies false is false. False implies true is true. False implies false is true, right? From what we did back in the last section, actually. Now let's look at the contrapositive. I'm going to give myself a little bit of room here because what I have to do, always start out with the same PQ that we make sure we get them in the right order. True, true, false, false. True, false, true, false. Now, I need to see the negation of P and the negation of Q. So I usually do them alphabetically. It's really up to you. It's false, false, true, true. False, true, false, true. And now we're going to look at the negation of Q heading towards the negation of P. Now the order makes a big difference. I'm going to come in here in red just to stress that. I'm going this way. My arrow's going from right to left. So false implies false is true. True implies false is the only time that that thing is false. False implies true is true. True implies true is true. So here's what I want you to see. These two statements, actually let me come back in here, put a big box around this, and come in here and call this, so remember this is the conditional, and this is the contrapositive. And look at this. These truth tables match up exactly. In the order from top to bottom, it's true, false, true, true in both cases. That is when you have equivalent statements. Yes, they are equivalent. If there was any change, if there was any difference, we would say that they were not equivalent. So actually the first part of your homework has you look at some statements and wonder and determine if they're equivalent or not. Yeah, they say determine if they're equivalent. So they're not known to be equivalent. So let's look at number 6. The negation of P heading to Q and P or Q. Well, let's look at the truth tables for each. Let's do the first one that's there, the first one we come across. If I look at let me make sure you know what I'm calling the first one. If we look at this guy right here as our first one, I'm going to need the negation of P, and then I have everything I need to do the negation of P heading to Q. I know it's true, true, false, false, true, false, true, false. Negation of P would be false, false, true, true. And then the negation of P heading to Q. So again, I'm going to go in red. The negation of P heading to Q. It's got to be this way. So you can look at your conditional sheet and determine false implies anything is true. So these first two are true. True implies true is true. And true implies false is the only time that the conditional is false. And we have that truth value. So I'm hoping that P or Q is true, 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 false. Let's go see what it is. P, Q. Do I have everything I need so I can do P or Q? In fact, you have this truth table written down. I'd want you to copy it so that I could see that you know what it is if you're looking at it. But remember, OR just needs something to be true. So these first 3 are true, but the last one is false. Look at that. They absolutely are equivalent to one another. 3 truths followed by a false in that order, right? So you're not looking for the same number of truths. You're looking that it is literally true, 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 false, true, 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 false, right? Over here I had 3 truths and a false, but these statements in 6 are not equivalent to these statements up here because they don't go in the same order. They match for the first one true, but they fail at the second one, right? And so then they're not equivalent. But these 2 right here in number 6 are equivalent. So interesting, saying that the negation of P goes to Q and or P or Q would be saying the exact same thing. Okay, kind of interesting in there. So it's going to be a great way for you to practice your truth tables, and all you're doing in the end is a comparison, right? You're just doing a comparison between these 2 ending values. If they look exactly the same, if you go down and they look exactly the same, then they're equivalent. So we would write, yes, they are equivalent. And they have more. So that is actually how you start out. In 1 through 10, they ask you just to establish equivalency by doing truth tables. And it's a really great way to just keep truth tables alive. Then you're rewriting statements in terms of their conditional and the contrapositive, inverse, and then converse. Apologize, that's the one I was missing, right? And you're just going to be asked to do that. Let's look at what's in the last little bit here, like what's in the last homework. So let's look at what's in the 36 block. So let's look actually at number 36 in general. So it says for the following exercise, use the conditional statement if some parallelograms are rectangles some circles are not symmetrical. They want us to use that to write some answers, right? So here's what happens in 36. 36 says, write the hypothesis. Write the hypothesis of the conditional statement. And this matches the ones that are before it. And label it with the P. And determine its truth value. Okay. So the hypothesis is the if part. So P is some parallelograms are rectangles. And P is true. A rectangle meets at a 90-degree angle, so a parallelogram looks like this, right? But some parallelograms would meet at the 90-degree angle, and so they would be rectangles. So P is true. 37 is going to have us write the conclusion of the conditional statement, label it as Q, and determine its truth value. So what is Q? Q's the result of that. Some circles are not symmetrical. Well, Q is false. All circles are symmetrical, right? They're centered about, their points equal distance away. They'll always be symmetrical about that center line. And then it says 38. 38 wants us to write the converse in words. Oh, well, we could do that and determine its truth value. So you may have to remind yourself what the converse is, and we'll end with this one because it just goes through the other ones, the contrapositive and the inverse. But the converse is, if we come up here, a flip of the two. Q implies P. So the converse is Q implies P. Now they want it in words, so it would be if some circles are not rectangles, or some circles are not symmetrical, then some rectangles are rectangles. Okay, it's just a simple flip of the two for the converse. And then you would do the same thing when asked about the inverse. Now, when we go to deal with truth values, we actually don't want to look at the words themselves. That's what's special about symbolic logic. We have Q implies P, which in our case, we don't have to do a full truth table because we know Q is false and P is true. So what's the truth value of the converse in this case? Because we have a false heading to a true, we know that anytime you have a false hypothesis, anything it goes to will be true. So the result of this is true. So the converse is true in this case because we have a false premise, or what they call a hypothesis in there. So everything from the beginning to the end is giving us practice with the converse, inverse, and contrapositive. In the midst, we're going to determine whether statements are equivalent or not by looking at their truth tables. And that should take you through all the homework. So I hope that you find this video to be very helpful. The book has really good examples as well. So reach out if you have any questions or concerns as you go through the homework. But I think you'll do really well if you stay centered on these definitions here, the converse, inverse, and contrapositive, and knowing that equivalent statements, you're building truth tables to show that they have the exact same outcomes, right? The exact same outcomes in the exact same order.